how many electrons can be placed in the fourth principal energy shell. So n equals 4. In order to find out how many electrons can be placed in there, we need to find out the number of orbitals, which is ml. In order to find out the number of ml, the orbitals, we need to find out how many subshells are there and what kind of subshells are there. Okay? And in order to find out the subshells, we need to find out the angular momentum quantum number. So n equals 4, then L has to be, according to the rules we learned, has to be 0, 1, 2, 3, all the way to n minus 1. So in this question, n equals 4, 4 minus 1, the maximum number should be 3 for L. All right? So then we have to have 1, 2. Okay, we have 4 subshells. All right? Still, do you remember the later presented subshell? L equals 0, S subshell, 1, P subshell, 2, D subshell, 3, F subshell, and so on and so forth. Therefore, now we have S subshell, P, D subshell, and F. Next, we want to find out the number of orbitals, or ML values, for each of the 4 subshells we just discussed. Okay, for each of these 4 subshells. So ML value, again, that should be from negative L all the way to positive L. Make sure you include 0, or another way to do it is ML equals 0, plus minus 1, plus minus 2, all the way to plus minus L. The total number of orbitals of ML values should be 2L plus 1. If L equals 0, that should be just 1, which is the S subshell. L equals 1, 2 plus 1, that's 3, P subshell, and so on and so forth. Okay, now you see for the S subshell, L equals 0, 2L minus 1, 2L plus 1, so then that should be just 0 because L equals 0. So therefore, ML equals 0, which means this subshell, there is 1 orbital, which is the S orbital. Now for P subshell, L equals 1, ML should be 0 plus minus 1. So therefore, the number of orbitals for P subshell, that's 0 plus 1 minus 1, that's 3. And for the S subshell, that should be 1, because the ML value, there's only 1 ML value. Let's do D. L equals 2, that should be 0, plus minus 1, plus minus 2. Then how many orbitals, or how many ML values? That's 5. 5 ML values means 5 orbitals, 5 possible orientations. Now, the last one. L equals 3, 0, okay? So then the total number of ML values, 2L plus 1, 2 times 3, that's 6, plus 1, that's 7. And count, that's of course, there are 7 values. Okay, so now those are the number of orbitals. What is asked now? We are ready to answer this question now. So how many electrons? Number of electrons. Okay, so we know each orbital can maximum accommodate 2 electrons. So for the s orbital, or L equals 0, the number of electrons 2. For p, 3 times 2, 6. For d, that's 10. For F subshell, that's 14. Now if you add them up, that should be 32 electrons. And that should be this answer. Okay? So be careful. It's us. What us is the electrons can be accommodated in the entire n equals 4 energy level. Okay? It's not in one subshell. It's not just like us for, n equals 4, then L equals 2. For that subshell, then that will be only 5 orbitals and 10 electrons. But this one's asked for all of the subshells contained in 4th principal energy shell. So therefore, you have to work out all of those subshells, find out the number of ML values, then you find out, of course, from there, the number of orbitals, then times 2 is the number of electrons. Okay, that's it.